So make sure you guys sign in, not only so that Atlas Club gets credit for hosting this session, but also each time we've done this, we've given out a certificate of completion to people who've been to every talk. Now, if you miss a talk for reasons that, happen, these will be posted and available on the WSOM media site, and you'll be able to review the videos and do a quick makeup assignment to get credit for having been here. At the end of this, anyone who wants to do an optional paper, not long, maybe 2 to 4 pages in length would be sufficient, can do so, and we'll be giving you guys a nice little extra certificate as a distinguished scholar of medical history. And it'll be something that we'll go back and forth with, edit a bit between you, myself, Lindsay, and others, and make sure that we can actually get it ready to put in your student portfolio, which is something that should be coming down the pipe very soon. Have you guys had any portfolio talks from people yet? Not really. So that might be coming down the way before too long. And last, before we get started, I want to thank Jonah Bowen hanging out in the back. Because of him, you can hear me, and you can see this. There we go. And that made it all worth it, right, Jonah? Okay, good. So let's talk about the history of medicine. This is a topic that we don't spend any hard curricular time on. You guys get a little bit of an introduction to the history of osteopathy in particular, but it's important to realize osteopathy didn't come out of nowhere. It was the product of a single person, but there's a huge background of medical history that's out there available, you can learn from, and a lot of times I think we do a disservice by making you think that only DO medicine only started with Andrew Taylor Still, that the entirety of Western medical canon is not something that applies to you guys. And it is. It's your heritage too. Now, one thing, I use the word Western. This is a series of talks on Western medicine and its developments, although it's going to include several other topics as we touch on them. When it comes to things like Eastern medicine, Ayurvedic medicine, I'm simply not qualified to talk about it. It's not that I'm against it. It's not that I'm trying to deliberately ignore it. I just don't have the perspective to offer you a really solid kind of overview of it. So you might want to talk to Dr. Schmidt if you want a little more information about things of that nature. And as time goes by, we can get that worked in. So let's get started on some of the more amazing and horrifying things that have led to the place you are right now. So, first thing we know about ancient medicine is what we're left records of. There may have been medicines, there may have been treatments, there may have been splints and things like that, but the only real evidence we have of very ancient medicine is trepanation. And trepanation was practiced throughout human history, and people got better at it as time went by. Which one of these survived the procedure? The one on the left or the right? Right. Nice smooth margin. That person actually survived the trepanation. How about the one on the left? Nope, that was fatal. Now, we don't have any hard evidence, but the idea behind trepanation is that they weren't doing it for the same reasons we do trepanation today, to remove hematomas. What do you guys think would be the purpose of doing a trepanation back in ancient times? What would you be trying to accomplish? I heard mumbles of evil spirits, and that's pretty much what it's expected. You were trying to deal with mental illness, things that we would call these days under the umbrella of mental illness, by drilling a hole in that person's head. Not the best course of action from our current standpoint, but the people who did this got very skilled at it. And in Peru, the obsidian tools they used were actually incredibly good at this. In the 50s, some Peruvian doctors actually did some skull operations with the obsidian tools that were used in the ancient times, and they worked really, really well. So these tools were actually pretty solid. Now, who's seen this game? Who's played this game? There's Operation. If this is a real thing, I really want somebody to find it for me. So if there's a trepanation game out there, please let me know. Send me the link. So, in addition to trepanation, another thing that we know of from ancient times is that there was a very intense spiritual aspect to the healing arts. It's so much so that they were seen as very linked and not even as separate considerations. Health and spiritual wellness were basically one and the same. Talking about Peru, one of the things we know from sources is that sometimes guinea pigs were held over the injured or affected area of a person and then sacrificed. And then their organs were inspected to see if that actually had any sort of a predictive value for how the person would turn out. Now that's in Peru. If we move back into the Middle East, in ancient Assyria, we actually have records of animals being sacrificed and their livers in particular being inspected to see how the patient was going to turn out. So this is called haruspice. It's basically telling the future by investigating animals' organs. And at the bottom left, we have a clay tablet that's been fired and turned really hard. That's basically a map of a sheep's liver that was used to predict how somebody was going to proceed as their healing process went forward. Now, in Assyria, there were also what we call kind of secular healers, people who just helped provide medicines, but there was still this very intensive spiritual nature of healing, where illness was the result of demonic possession or punishment from on high, and that the animal organs were inspected to try to deal with that and figure out what to do. Now, Hammurabi was an ancient Assyrian king who laid down the set of laws called the Hammurabi's Code, and physicians were mentioned in here. So, if a doctor has treated a free man with a metal knife for a severe wound, has cured the free man, or opened his tumor with a metal knife and cured his eye, he shall receive 10 shekels of silver. Let's compare that to what happens if you fail. If you destroy the man's eye, cause him to die, the physician's hands shall be cut off. So malpractice doesn't look so bad in comparison to what you might have had to deal with in ancient Assyria. Now, moving a little forward in time, we come to Egypt. And when we think of Egypt, a lot of us think of the mummies and the process of mummification. And what's truly amazing about this to me is that mummification was a very intensive process where the organs, except for the heart, were removed. They were put in jars, these canopic jars, that were then resealed in the body. The body was treated with various preparations to mummify it, to dry it out. The brain was actually removed with a hook. And a lot of times people say it was hooked out. People who've actually attempted this say that that's not how it works. What they did was they stuck it in there and kind of swizzled it around to liquefy the brain and then drain it out the nose. But there was a lot of anatomical preparation involved, but none of this, none of the mummification anatomical know-how actually translated into the Egyptian health practice. It didn't translate into how people were actually cared for. What did happen was that the theory of disease at the time was called flux. And the flux happened when you ate bad food and it moved into your gut and then would flux or move to other parts of your body, causing swelling, infection, or tumors. So you're trying to deal with the flux by getting things back into balance. I should mention, if you haven't got the sign-in sheet, make sure as it comes around, you get it before you're done. Make sure you've started out. Lindsay is holding it right there. So how would you treat people to deal with this flux and restore balance? Things like massage, bleeding, enemas, purgatives, things that would allow the body to expel some of the nasty stuff were largely what was used to get them to be better. The Egyptians also had a massive pharmacopoeia of different medical techniques and different preparations they could use. We'll talk a little bit more about that in the third lecture. But what's interesting is their know-how from mummification did not translate into medical practice. So there were quite a few different things recorded, and in addition to the pharmacy, one thing that Egyptians did very frequently was incubate a sick person. So if you were sick, you would go to the temple of Imhotep. Imhotep is thought to have been a real person who served one of the pharaohs and then was added to the pantheon of Egyptian gods. And at the temples of Imhotep, the sick people would be allowed to rest. The priest would come around and try to divine what was causing their illness and what they could do to change their life to make it better. What's really interesting about that is that Greek mercenaries living in Egypt took that practice back with them to Greece. And instead of Imhotep, we had Aesculapius, temples of Aesculapius, and who may have been a real person, but if so, was also added to the pantheon of Greek gods. These temples were usually in high, hilly areas with a lot of fresh air. People were allowed to rest there, and they were sent there to wait for what's called the therapeutic dream. They'd have a dream that would direct them on how to change their life and improve their condition. Now, these temples worked pretty well. One reason was because they had a lot of snakes around them. What do we associate snakes with? Or let me rephrase that. Why are snakes a good thing to have in this day and age, in ancient times, in an area where people want to get well? Yeah, they eat vermin. They take care of rodents, things like that. So it's a relatively healthy place to be. These were non-poisonous snakes. They weren't biting people. And the other reason these temples worked well is most people get better. whether we do something or not, most people tend to get at least a little better or they die. And we were always able to explain away the death as an unfortunate thing and then take credit for them getting better. Now that sounds a little bit snarky and cynical, and it is, but it's also true. So you can always count on people to get better, at least in some degree, even if you're doing something that only peripherally addresses their problem. Now back to snakes, they became the symbol for Aesculapius. Now notice something. The caduceus with two snakes is actually held by Mercury. It's actually a different caduceus than the one on the right, held by Aesculapius. So the double snake is actually originally intended to go with commerce and business and communication, whereas the single snake around a stick was originally linked to healing. So, hooray for us, look at that. One snake, there we go. Now, Aesculapius had several mythological daughters, and two of them are particularly interesting in health. They were Hygeia and Panacea. Hygeia, where we get the word hygiene, was involved in actually preventing disease, public health, public welfare, clean food, clean water, preventing disease. Those were the areas that were overseen by Hygeia, whereas Panacea was the goddess in charge of actually remedying illnesses that were already there. So even in ancient Greek times, we've got the split between preventative medicine and intervention in the case of illness, and they were personified by these two goddesses. So the next major character we come up with is a person we know to have been real. There's evidence out there that Hippocrates from the island of Kos actually existed, and Hippocrates did something that is really pretty phenomenal. It's basically assumed these days, only because Hippocrates did this several millennia ago, but he took medical practice and removed it from that spiritual setting where disease was caused by spiritual causes. Hippocrates felt that disease and health could be dealt with in a physical way using material methods, and that would work. Now, we all know that some aspects of spirituality play into people's health, but the assumption is disease isn't something we have to go sacrifice a goat over. It's something we can actually run tests over and make rational interventions to help people, and this all got started because of Hippocrates. That being said, his method of classifying and organizing disease makes no sense to our modern sensibility. So here it is. We had four humors circulating through our body. Blood corresponded to air, which gave us energy, and if we had a lot of blood coursing through our veins, we're sanguine, we're really happy, really energetic. Yellow bile corresponded to fire, that's anger. If you had too much yellow bile, you were choleric, you were angry and bilious all the time. Black bile was another humor, and black bile translates as melos choli. You're very melancholy, you're sad, you're slow, you're not really energetic. And lastly, phlegm was the fourth humor, and that kind of made you slow and sluggish, much like we imagine. If you have a head cold now, you're very phlegmy. The Greeks actually thought phlegm was your brain leaking out your nose. So there we go. So those are the four humors. So how did they manifest? So we've got them on a kind of diametrically opposite kind of organization here. Hot and cold, dry and wet. So the humor that is both hot and wet was blood, and that corresponded to fire. So if you're really, really working hard, you've got your blood circulating, you get hot, you get sweaty. Likewise, the dry and hot humor was yellow bile. Black bile was cold and dry, and what's cold and wet, phlegm, is cold and wet. So these humors and their balance in the body was different from person to person, but had to be adjusted to the right level for each person. And if somebody's got too much blood, what do you guys think you have to do? You take some of it out. You could use enemas, massage, purging, things like that. If people had bile come up when they vomited, that was felt to be adjusting their yellow bile. So those were the sort of interventions people had. And the balance of these made your personality, at least the baseline for it. So if you had an excess of blood, you were sanguine, you were energetic and happy. If you had a little too much melancholy, you had black bile in excess, you were a little bit upset, kind of slow, ponderous. If you were phlegmatic, you were very slow and ponderous and kind of just sluggish all the time. And if you were choleric, you were just angry and wanting to stab people, apparently. So how did Hippocratic physicians treat people? They used, like we just said, bleeding, purging, puking, cupping, massage. There were actually manipulative treatments suggested by the Hippocratic physicians. There was actually an old illustration of a machine that was there to kind of do a spinal adjustment on someone. So it's a little more kind of intense than that one that we have in the OPP lab. That one in the lab is a little bit scary, so it might kind of crank you up pretty good. If you ever get a chance to see somebody use that, it's a work of art, that big table. So moving forward, the Hippocratic physicians gained a great deal of precedence over their competitors because they really looked intensively at patient history, patient progression, trying to make sure that the intervention happened at the right time and that the patient was supported throughout. And they gained a great deal of credibility as they traveled and largely displaced other healers that weren't hewing to the same method. The other thing that's really famous about Hippocrates is your MD counterparts take what oath? The Hippocratic Oath. Hippocrates also worked to create a professional identity for healers, to make it sure that people knew the Hippocratic physicians were different from the other stonecutters, barbers, other people that were operating at the time. And it's because the students of the Hippocratic tradition were told to take an oath and behave in an ethical manner. People like that, still do. Moving forward, the humoral theory of disease and health really caught on, and several other Romans and later Greeks elaborated on it. In Alexandria, in Egypt, there were two Romans who investigated anatomy and really got started what could have been a very early exploration of human form and function. Sadly, it fizzled out. But Herophilus was an anatomist who tied the pulse to the heartbeat. Seems obvious to us now only because we've been brought up to tie those two together. So the pulse and heartbeat were thought to be connected. He did several other things correlating anatomy to function and pathology. Those works have been lost, and we largely only know about him from other people's writings about him. Erasistratus worked up a little bit of a variation on the humoral theory called the pneumatic theory. In this theory, we have what's called pneuma, or air, circulating throughout the body in addition to our blood, and that's what allows us to move and think and do all the things that we do. We'll elaborate on that in just a second when we get to the next guy, Galen of Pergamon. Galen is the next big name in Western medical history after Hippocrates, because in the several hundred years since Hippocrates, the teachings had been diluted, polluted. People had attributed their own writings to Hippocrates, and it was really unclear what things actually were Hippocratic in nature. Galen, a Greek living in the Roman era, decided to reform and purify the Hippocratic writings through active research, through active record keeping, and he did a really good job. Before he became a high-profile physician to the Emperor Marcus Aurelius, he was a gladiatorial combat surgeon. And at a time when nobody really got a chance to see human anatomy due to the conjunction against doing dissection, being a gladiatorial surgeon was about as good as you could get. Thereafter, he started doing lots of experiments. He elaborated on the humoral theory and came up with a comprehensive physiology, anatomy, and treatment plan to deal with it. And sadly, there were a lot of errors in his system. Now, everybody makes mistakes. The problem is you have to know that you're fallible. And Galen, the word ego doesn't even come close. Here's what he said regarding his teachings and how much research should be done thereafter. Essentially he said, whoever seeks fames by deeds, what you can do, not alone by learned speech, need only become familiar at small cost of trouble with what I have achieved through active research in the course of my life. Basically saying, I figured it all out, don't bother, just do what I said and everything will be fine. Not really the spirit of modern scientific investigation, and there were lots of problems with his theory. We're going to do a quick run-through of his theory of pneuma, and just follow along with me. Those of you who know your anatomy can kind of have your heads explode very gradually as we work through this. So, you eat food, and chyle is what was digested from food, and that traveled to the liver, and it became invested with the first type of pneuma, which was called natural spirit. Blood from the liver washed out through all the veins, and once it got to the heart, was pumped. And one place it was pumped was to the lungs to purify that pneuma. And at the same time, we've got air coming into our lungs and traveling to our left ventricle through the pulmonary veins. So lots of air running through our pulmonary veins. Makes sense, right? But don't worry. There were holes between the right and left ventricles that allowed blood to seep from the right ventricle to the left, mix with the air, and at that point we had a new type of pneuma. So that vital spirit and air is traveling in the arteries, and it gets pumped up to our brain. And there's a network of blood vessels at the base of the brain, according to Galen, called the miraculous network, the rete mirabili. And that transformed that pneuma into animal spirit, or sometimes called psychic pneuma. And that's what actually went through our nerves, which Galen said were hollow, to fill up our muscles. So just take a second and kind of put your hand on your biceps. So according to Galen, every time this happens, we've got pneuma being pumped into our bicep like a balloon. And feel it. Now, if you didn't know any better, and some doctor told you, yes, that's your psychic pneuma, filling up your muscle. Sounds okay to me, right? So this was the medical theory according to Galen. And he told people that he had got it figured out and he was right, and that's what they should do. And he was believed. He was unquestioned for roughly 1,300 years. 1,300 years. Why? Well, what Galen wrote was very, very easily swallowed and easily adapted by civilizations that came into the Middle East and Mediterranean thereafter. He thought that the work of creating the body was done by a godlike entity called the demiurge, and that was relatively easy for monotheistic cultures, so the later Christian, Jewish, and Muslim cultures in that area, to adapt. They said, okay, it's not the demiurge, it was obviously God that did this. So it was easily adapted into later cultures. Galen's writings were widely disseminated in Arabic, Greek, Latin, many other languages, so he was widely available, and the Middle Ages or medieval era was really, really happy with unquestioned authority. A good authority was what you wanted to refer to. These days, an argument based on authority is not considered to be a good argument. In the Middle Ages, it was absolutely a good argument. You went to the authorities to make sure that you were correct. So, all of this put his experimental results ahead of his methods. He did some amazing research. He figured out how nerves work. He tied motor function to nerves. He figured out how the lungs inflate. But no one followed up on his methods. They only wanted to parrot what he said was the result. So let's run through a couple things that happened during the period of time when Galen was unquestioned. Any history buffs in the audience, get ready. So what happened for those 1,300 years when medical practice and theory remained completely or almost entirely stagnant? What do we got? The Roman Empire. Anglo-Saxons invade Britain. The Muslim conquest of Spain. Constantine moves the Roman capital of Constantinople. The Roman Empire falls. Then Charlemagne was crowned the first Holy Roman Emperor. Then the Vikings raid throughout Europe, all around the Mediterranean. The Magna Carta limits British royalty's authority. The Crusades, lots of them, were launched from Europe all over the Mediterranean area. The New World was discovered, and the Reconquista of Spain was completed at that time. All this stuff happening, followed by the Protestant Reformation in Europe, while medical practice did almost nothing. So there we go. Oh, and then we got the Renaissance. And the Renaissance is where we're heading, because that's when these authoritative versions of things started to be noted as being in contradiction to actual lived experience and experimental results. All right, so once Galen was overthrown, it was largely because people started doing experiments again in a similar manner to the way he did. Now, before we move on to the full later Renaissance, let's talk about the Islamic empires that largely inherited the culture from the Greeks and Romans. After Rome fell, most high Western culture moved into Damascus, Baghdad, and Constantinople as well, so a little further to the east in the Middle Eastern area. And science, chemistry, astronomy were really highly investigated and elaborated on by physicians and scientists, what we'd call scientists, in the Muslim empires. And it's important to note, these were not only Muslims. Jews, Christians were allowed to work and do their investigations in these empires. Most of the time, people who were not Muslim had to pay us tax for the privilege of living in these societies. But these places maintained that Western practice while Europe kind of descended into what we can call the medieval or dark ages. Now, the Muslim physicians largely ignored surgery. There was a prohibition against cutting the body, but one thing that they were really good at was optics and dealing with the eye. Cutting the eye was not conceived of to be as bad as wounding the body, and cataract surgery actually came a long way in these empires. So what's a cataract? What happens when you have cataracts? Foggy lens. Your lens gets cloudy, gets foggy, and so they actually figured out you could use a suction device to pull the lens out. And when you can't see anything, and suddenly you can see stuff kind of blurry, that's a big improvement. So those surgical improvements were kind of brought forward in these times. And so let's go through a few of the big names. First up, we have Rhazes. So Rhazes did something else that the physicians and scientists in the Muslim empires did a lot of, which was categorizing things. Think about how many diseases have a fever. Think about how many diseases have a rash. If you don't have any way to categorize how these diseases progress, you're going to have a really tough time knowing actually what to do to treat a disease. So coming up with catalogs of ways to classify these diseases and know what their progression was going to be was pretty important. And Rhazes was one of the big first investigators in that. He did a lot of alchemy. Now, we think of alchemy these days as kind of a bad thing, but alchemy really is just early chemistry. The goals were often different. The transmutation of metals, coming up with the elixir of life, but the methods used by people like Rhazes really set the stage for distillation, purification, and analysis of structures to come up with modern chemistry. And if you remember that al is just the definite article in Arabic, al-chemia becomes chemistry, and that's really where that word develops from. So he was a free thinker. He actually publicly doubted Galen. He didn't think humoral theory was all that great, and he wanted to elaborate on it. His free thinking got him into trouble, and there's a variety of versions of this, but he was actually beaten and went blind in one eye because his theories offended either a local religious leader or one of his patrons, as he was doubting the established authorities at the time. So next up, we've got Ibn-al-Haytham, or sometimes known as Al-Hazan. He did a lot of different things. He was not just a physician, not just a scientist. A lot of people had very wide-ranging interests back in these days. And one thing that he really made a big impact with is coming up with a theory of vision that actually worked. Prior to Al-Haytham, the idea was that our eyes sent out eye beams, and they hit stuff and rebounded back to our eyes, and that's how we saw things. This didn't really make a whole lot of sense. There were actually even less sensible theories out there than that. There was one theory that everything in the world was constantly peeling off its outer skin like an onion and flooding our eyes, and that's how we sensed stuff coming at us. He came up with the idea that light was reflected off of structures, and that's what our eye detected, and by and large, he came up with a modern version of optics and how the eye is able to focus using the lens at this time. So the work in optics, both human eye as well as the physics of optics, was really done to a high degree back in these days, especially because of people like Al-Hazan. He also had this amazing idea that we should come up with ideas but then actually test them. Crazy, right? Next up, we got Avicenna. So Avicenna was a very devout Muslim who wanted to tie the teachings of Aristotle to the teachings of the Quran and therefore try to find a way to prove the existence of God. He wrote a huge, huge book on medicine, the Canon of Medicine, in 14 volumes, and this book was used for over a millennia. Not that it was super, what we'd say, accurate according to our normal perceptions now, but it was a vast improvement. And what did the Middle Ages and early Renaissance really like? They liked things standardized. They liked having an authority they could refer to, and Avicenna became one of those authorities. He supported what's called the miasma theory of disease, and that is that bad air causes disease. So if you have something really obnoxious hit your nose, that could make you get ill. And we'll see that elaborated on as we move back into Europe and how it's going to deal with invasions of during different times of war, as well as the plague, and how the miasma theory of disease didn't quite create our modern understanding, but set the stage for us to understand contagion and eventually germ theory. And we got Ibn Rashid, who compiled a great deal of Galen and really tied Galen to Aristotle, and that's one reason that Aristotle became so popular later in the European universities. Now, I've mentioned a couple times that this learning is taking place in Damascus, Baghdad, and eventually makes its way back to Europe. The last big name I'm going to go for before we get to that transition is this guy, Ibn-al-Nafis. So he did other studies on vision, and just like Al-Haytham, came up with different ways to describe how the eye works and made it accurate. He also described the circulation. He figured out that the heart pumped a circuit to the lungs and likely a circuit to the rest of the body, and that the blood in the lungs had to somehow make its way back to the heart. And even though there were no microscopes, he theorized the existence of capillaries. Now, this information was lost until quite a bit later, but he did accurately describe quite a bit of the circulation back in the 1200s. And he knew that Galen was wrong about many things, like the holes between the ventricles. He had really set up a good, strong investigation regarding human form and function. It's actually thought that he did some human dissections despite the prohibition against it at the time. Depending on where you were and who the local civil and religious leaders were, you could sometimes skirt certain laws, and it's thought that he might have done so. And I really like this quote: "We shall rely necessarily on verified examinations and straightforward research, disregarding whether our opinions will agree or disagree with those of our predecessors." Kind of sounds like science, right? So we've got a really great, fertile ground for a possible scientific revolution to occur in the Middle East back in the mid-1200s. So everything was going great. What went wrong? Anything? The Mongols. Oh, there we go. So the Mongols decimated the Middle East. Now, who's ever heard the term, "the rivers ran red with blood"? Okay, nobody watched Conan the Barbarian when they were a kid? Okay. So you've heard that, the rivers ran red with blood after a big battle. The rivers in Baghdad were said to have run black with the ink from all the books and things that had been thrown out of the libraries and thrown out of the various houses of learning. So there was a huge loss of information when the Mongols decimated Baghdad, other places like that, and the scholars who were present at that time had to flee. They were just going to be completely wiped out otherwise. So the Mongols did a tremendously, effective job of wiping out that high civilization. Now, fortunately for the rest of history, there was a place in Europe that had come into existence to receive these scholars and people who'd been kind of shuffled out of their existing location, and that was the medieval university. The universities had been founded in southern France and northern Italy, and these were largely there to teach theology, medicine, and law. Which do you think was on the bottom tier of that hierarchy? Medicine. Yeah, get used to that. That's just how it goes. But the medieval universities were really happy to get these scholars from the Middle East or Constantinople later when it fell, because they brought with them more authentic, closer, and better translations of the various books that people wanted to consult. And the universities at the time were all about the written word. It was all about that accordance with authority. But that influx of new and more accurate material revolutionized the scholarly work at the time. Now, in terms of how this affected medicine, it sort of did, but sort of didn't. It brought more accurate translations, but it didn't allow for a great deal of elaboration on what Galen had already been, what was already present from the Galenic corpus. So essentially, human dissection was allowed in the 1400s under Pope Sixtus IV. One of the nice things he did a lot of other bad things, but amongst the things that were allowed was that executed criminals could be taken to a medical school and dissected for the benefit of the students. Now, this is pre any sort of body preparation, any embalming, so it had to be done quickly. Largely, we started with the organs and then moved on to the limbs, which could be kept a little while longer. Now, you'd think that would help people see the errors of Galen, but there's a problem. People really weren't looking for errors. Take a look at the picture here. I know it's a little blurry, but where's everyone's attention? Is it on the body? Not really. So what happened was you largely had several hundred years of propaganda for Galen in the guise of human dissection. The professor was sitting up there in the podium professing, like literally reading off a text of Galen, maybe not even looking at the bodies. The professor was professing. Meanwhile, an instructor had a stick and would just kind of point, there's that, there's that. And the person actually doing the cutting was probably a butcher or a barber who had no anatomical knowledge other than what was professionally known to him through his work. And the students may not have even been paying attention. It was largely there to support Galen. So what happened? Couple things. The decree allowing dissection to occur applied to doctors, medical students, and artists. Artists were there so that they could create a more accurate version of the human form and make their art that much grander to serve their patrons. So Leonardo da Vinci did many, many dissections and actually wrote down, drew a lot of things, and was able to spot several errors in Galen. But Leonardo was a little paranoid and did not want a lot of his findings to be made public. There were several things that probably would have gotten him arrested for heresy, apart from his anatomical work. So he was a little bit cautious. But take a look at this. These are all drawings by Da Vinci prior to any real revolution in anatomy. He's got the skull opened up, he's got the air spaces, he's got freaking cross sections of the lower limb. That wasn't something we really looked into until the 1980s. So just one more example of how he was so far ahead of everything else going on at the time. But none of it was distributed. He'd planned to make an anatomy atlas with a colleague, never came about. He didn't finish a lot of jobs. And this work was largely lost until the 1800s. So in addition to Da Vinci, Michelangelo actually dissected. He actually did a job carving an altarpiece for a church that was attached to a church hospital. And because of that work, they allowed him to actually dissect some bodies. He didn't particularly enjoy it, but he did it diligently because he wanted to be a better artist. There's actually a story that his father didn't approve of him being an artist. He wanted him to do something else. So his father caught him sneaking in one night from dissecting bodies. Said, "You were dissecting, you were doing art." Like, no, I was carousing with loose women and gambling. So apparently that was better. But Michelangelo, they're still discovering little things that he snuck into his art. So take a look. So he had little anatomical tricks that he threw into his art, and we keep on finding them in various works. So he knew what he was doing and tried to make sure that the anatomical realism wasn't just in the muscles and the skin and the appearance, but actually had other representations as well. So how did things change? Things changed in the 1500s when the professor of anatomy at Padua, a guy named Andreas Vesalius, who was a very well-trained physician, figured out that there were just problems with Galen, and they weren't just small errors, they were wrong. There were things that were badly wrong. Now, he'd grown up in Flanders on top of a hill, and to get down to the main town, he had to walk down the hill. In between was the hanging ground where criminals were executed, and at the time, bodies were left on the noose until they just withered away and fell away. So every day he'd be walking past decomposing bodies, and he'd start playing with the bones and the ligaments, and just by playing with these bones and ligaments, he probably knew more about actual anatomy than most physicians would ever learn in their life. So when he went to medical school and became a professor, he had that massive wealth of knowledge. And he decided he didn't really like the way he was taught. He didn't like that professor at the podium. He taught with a skeleton, he taught through active dissection, and as time went by, he found more and more errors with Galen that he couldn't ignore. And they weren't trivial errors. The muscles and the attachments were just wrong. Blood cannot move from the left and right ventricles in humans unless there's a defect. And the cornerstone of Galenic physiology, the thing that allows psychic pneuma, an animal spirit, to move our nerves, the radium mirabile, does not exist in humans. Other animals have one, giraffes in particular, some apes, but not humans. And so very, very poetically, he kind of figured out why Galen had so many errors. And it's because Galen had never dissected a human body. Or as he put it, Galen was misled by his monkeys. Galen did a lot of dissections on different Barbary apes and other animals, but never a human. And that's where these errors came from. So how do you think all that went down when he published it? Really poorly. He was not hounded from his job, but all of his colleagues just couldn't believe he had the audacity to cast doubt on Galen. His actual teacher said that if there were errors in Galen, it wasn't because Galen had been wrong, it was because the human body had changed in the intervening time. So people were really wedded to the authority of Galen. Vesalius stuck it out as long as he could. He eventually got sick of it, and before he left Padua, he burned all of his research notes. I have to imagine him doing the medieval version of flipping the bird to everyone as he left town. He became the physician to Charles V, the Holy Roman Emperor, also the same as Charles I of Spain, same guy, and then his son Philip II. Vesalius rather later died on a trip back from the Holy Land on a Greek island and was buried there. And that might have been it, except he wrote up his findings. He wrote up his findings in a book called De Humani Corpora Fabrica, on the makeup of the human body. And in addition to accurate descriptions of anatomy, in addition to actually telling people to go and look if they didn't believe him, like a good scientist should, he had fantastic illustrations. Now here's what illustrations tended to look like prior to Vesalius. Even if we give them credit as schematic and not necessarily realistic, what is that? Even if it's schematic, it's so far off, it doesn't make any sense. The heart, is that where the heart belongs? The answer is no. The answer is no, that's not where the heart belongs. So the anatomy that was portrayed was so far gone from reality, it was basically useless. Now, Vesalius had some help in putting this book together, and his help was a very, very talented student of Titian's, a guy named Stephen von Kalkar. And here are some of the illustrations from De Humani Corporis Fabrica. Now, there are some errors in Vesalius. He's not perfect. But if I had to, I could teach from these images. It's accurate enough that you can teach modern anatomy from the work that Vesalius did back in the mid-1500s. That's how good the artistry and the descriptions actually were. So, quick aside for me personally, my best day ever. Was it the day I got my PhD? How about my wedding? Oh, that was a great day. Oh, the birth of my children. Oh, that's awesome. But then there's the day I got to inspect an actual copy of De Humani Corpora Fabrica. And I'm never going to say which one it was. Okay. So before we end, we're going to give a quick little jump into the next set of lectures by talking about one last person, William Harvey. William Harvey independently rediscovered the circulation of the blood. Now, yes, it had been discovered by Ibn-al-Nafis in the Middle East, but that knowledge had been largely lost and not imported into the European medical lexicon. So when he rediscovered this, he did it a couple different ways. He theorized that there had to be capillaries because, as Galen described the blood, it came from our liver, washed out into our organs, and that was pretty much the end of it. So it was just being washed out, somehow absorbed, something like that. And he did the first quantitative study in medical history. So every time you guys have to do an equation on an exam, you can thank William Harvey. But he figured out that basically if the heart beat a certain amount of blood and had a certain amount of heartbeats every day, we'd be producing roughly 540 pounds of blood every single day. And he thought that's impossible. There has to be some way it's recirculating. He also theorized that there were capillaries, and he described how transitional circulation works from the fetus into the mature circulation at the time of birth. He did a really clever thing. He would inspect the hearts of cold-blooded animals like lizards and snakes, and he'd cool them down on ice so that their heartbeat was so slow he could actually see the contraction sped from atria to atria and then thereafter to the ventricles. So he did some really cool stuff. And that finding was largely ignored at the time. He wrote it up in a book called De Mortu Cordis, The Movement of the Heart, but it became the foundation for most of Western medical thought thereafter. And so we're going to call it quits for today, and we've got a good starting point for the next talk. That's going to be concepts of health and disease throughout history, how we actually think about health, illness, and the start of modern pathology. Where is disease located and how does it progress? That'll be coming up September 21st at noon. Thank you guys very much.